Good morning, good afternoon, everyone. My name is Chris. I am a technical sales specialist here at Global Test Supply. Thank you, everyone, for joining our webinar this afternoon or this morning, depending on where you're from. This is the Acoustic Sound Imaging webinar and is brought to you by Global Test Supply University. As a reminder to all before I intro our presenter today, please keep yourselves on listen-only mode throughout the presentation so we have no audio issues or any background noise that can disturb the presentation. As well as if you have any questions throughout the presentation, please insert them in the chat section. Adam and I will be going over any questions that come in throughout the presentation, as well as have some time at the end of the presentation to go over everything as well. So I am joined today by Adam St. Clair. He is an industrial imaging category manager for Fluke. Adam has been with Fluke for about 8 years in several different roles, including roles in the factory and in the field. He's currently part of the industrial imaging business unit, working to launch new industrial imaging technology into the industrial space. I will be transferring the presentation over to Adam. Thank you everyone again for attending. Adam, it is all yours.
Right on. Thank you, Chris. Let me get my screen pulled up. If you could, let me know when you see it.
Yeah, we can see it perfectly. Thank you.
All right, right on. Well, welcome everybody who joined. I'm looking forward to spending this hour finding a good balance of both information and interaction. So I would encourage everyone on the call here to put all of your questions into the chat box. I will be going through a lot of the content and information that you all signed up for, but also breaking at different points to make sure that I'm answering any questions that come up. I know it can be a little bit monotonous to just sit and listen for an hour at a time. So please keep your questions flowing in. Chris and I will do a good job of getting those questions answered as we go through. So what I've got on the agenda outside of all of the questions that you guys have is to introduce you all to what acoustic imaging is. So it's a new technology, and while it's relatively simple, I want to spend a little bit of time just kind of level setting this group on what the technology is, how it works, and what it's capable of. And then we'll get into some of the specific operation of the Fluke II900 and some of the practical considerations for use. So understanding how this tool is going to operate and act in different environments, and taking into consideration some of the different environmental impacts and things that will kind of potentially create a little bit of a learning curve or whatever. I want to just understand, or make sure you all understand, kind of how this is going to look and feel in your environment. And then finally, we'll talk about some of the opportunity that this tool provides in estimating both the size and the cost of leaks, and how you can capture images and videos for reporting purposes. And then we'll round it out with some application examples. And what I want to focus on in the application examples is not so much the really detailed dive on specific applications, but more just kind of give you all a feel for how our customers are using this technology to help them add value or solve problems in their environment. So that's what I've got that I want to share with you. But again, I also want to answer any specific questions that you have. So look forward to hearing what those are. Okay, so what is acoustic imaging? In a nutshell, it is turning sound into a picture. So similar to thermal imaging, where we're able to kind of give your eyes something that they can't see through heat. This is doing a similar exercise, but it's helping you see things that you can't or that you can hear. So it's really it's taking a sound, the location of a sound, and overlaying that on a visible light image to help you pinpoint areas where sounds within a certain frequency range are coming. So Here's a look at the II900, and the gray part on the front of the device is called a sensor head. So that sensor head is really made up of two components. It's got 64 acoustic microphones. Those microphones are pointed forward, and they're listening for any sound between 2 and 52 kilohertz from about 150 feet away from the sensor head. And then you've also got a visible light camera in the center of that sensor head, which is capturing a visual representation of anything that you're pointing the camera at. So it's essentially a video camera with a bunch of microphones around it. And then if you flip the unit over, this is what you see on the front of the device. So this is what you'd be looking at when you're walking around your facility or walking around an area where you're looking for any noise anomalies. This is what you're actually going to be looking at. You've got an LCD screen that shows the visual light, so like what you see with your eyes. And then you see that little blob on the screen as well. That's the visual representation of an identified sound within the frequency range or frequency band that you've identified you want to visualize within. Then you've also got two buttons on the screen, so an on and off button in the bottom left-hand corner, and then you've got that long, skinny green button. That is to allow you to capture either pictures or videos, depending on how you've got the camera set. The rest of the interaction with the tool is done on the touch screen to access the different menus and things. And I'll walk you through quickly what those different kind of menu options are. Okay, so we already went through the buttons, pretty straightforward, two buttons. Anything more and I get confused anyway, so that works out well. And then the different menu options on the screen. So if you just hit the screen, the different menu options will pop up. So what we'll do is we'll start from left to right. We'll go from left to right, and then we'll talk about the frequency range, which is on the far right-hand side after we get through the other menus. So to start, in the upper left-hand corner, you've got this image icon. If you select that icon, it allows you to toggle between capturing images and videos up to 5 minutes. And then there's also an option to go into leak queue mode, which is a mode that will allow you to capture images in a way that will help you to quantify the cost of that leak in terms of energy savings or in terms of kilowatt hours. So like the amount of money you pay on a utility bill. Or if you selected a specific direct cost gas, it could do that as well. All right, so image will allow you to change between the way that you're capturing and storing the data. The next option there is memory. That just gives you access to the library, any of the images or videos that you've got stored internally on the device. You can access them there in the different folders that you've created. And then acoustics. This is a setting that will allow you to make some changes to how you're visualizing the sound. So if there's specific decibel ranges that you want to hone in on, or different acoustic settings that are more fit for your specific application, you can fine tune the acoustic ranges and settings there to be the best fit for your application. It's defaults in a mode that our algorithms and our engineers defined as the best for identifying compressed air leaks, but you can make some adjustments there. Then you've got palette that allows you to change the colors that the sounds are represented by on the screen. Markers will that center box in the center of this image here, that's what the marker is. Really what that's doing is it's allowing you to understand kind of the amplitude, so what the decibel rating is or the decibel level is for all of the sound in the field of view represented in the center of the screen there. And then finally you've got settings. This is just where you can change the language, date, time. If you are more comfortable with metric or imperial units, you can make those changes there. And so just kind of the standard settings preferences can be addressed there. And then on the bottom of the screen, you've got, date, time, battery life, pretty standard. We already talked about that decibel level. And then finally, on the right-hand side of the screen, this is where you've got your frequency range displayed. So as I said earlier, this camera is able to visualize sound anywhere from 2 to 52 kilohertz. But what you can also do is isolate a specific band or range of sound that you want to visualize. So you could say, hey, I only want to visualize sounds. In this case, it's set to visualize between 30 and 50 kilohertz. Why that's important is, our ears only hear sounds within a certain range. So like when you walk into a really noisy factory or environment, noisy to us, you can still use this tool to pinpoint and identify different leaks, because typically those leaks are happening at a lot higher frequencies that our ears can't even pick up on. So what this allows you to do is isolate the specific frequency range where you would suspect a leak to be creating sound within, and ignore all of the really noisy motors, machines, and processes that are happening around it. So you've got the circles that are on the top left and bottom right hand side of that frequency range box that you see. You can just push and hold, or kind of drag those circles to tighten that band. And then you can also push and hold in the middle of the box and slide that band up and down to get to a spot where you're ignoring all of the ambient noise, and you're getting a tight enough band to get the desired level of sensitivity for the specific leaks that you're looking for and trying to pinpoint. So we'll talk more about that as we go, but that's kind of a high level overview of how to operate the instrument and what you see on the screen. So again, image mode, you can toggle between images, capturing images and videos. Here's a quick view, although it's just a single image, of what that memory looks like. You can also create and organize images in specific folders, if that's helpful. If you've got a lot of folks using it, or a lot of different areas within a facility that you're capturing images. Here's a look at the different color palettes that you can select. So just kind of a preference thing here, or for those of us that are colorblind, you've got a grayscale option as well that will just make it easier for the eye to differentiate between the different colors on the screen. And then the markers, turning those on and off. So relatively simple explanation of the technology and of the tool. And really, that's just kind of a testament to the technology itself. It is extremely simple to use. It doesn't require a lot of training. Really, anybody that's able to turn this thing on can use it effectively. And so not a lot of explanation required there. Point and shoot, and adjust the frequency range to mitigate the ambient noise, and you're off and running. So now let's get into some of the practical considerations for use. So I put this in here because I wanted to give you all a feel for what this instrument or this tool is like in an actual environment. So what I've got here is a few different videos that will help you to understand what you would actually see on the screen when you're out looking for leaks. So the first thing to keep in mind is that sound reflects. So if you have a sound that's created by an air leak, it's going to have sound that broadcasts out, and then it will bounce off of different surfaces, right? So when you go out with an i900 and you've identified a leak, you want to kind of run it through a little bit of a sanity check or a logic test to make sure you've actually pinpointed the source of the leak as opposed to a reflection of it. So you turn the camera on and you're scanning with the unit different areas where you would expect a leak could possibly be. And what you're looking for is exactly what you see on these images, this target, a circle with all of the different colors on the color palette represented, and you're looking for that circle or that target to stay in one spot. So if you find a target and you move left and you move right and you kind of get on top of it, or you maybe move further back from that that target or that circle, if that target moves, what you found is a reflection of the source of the sound and not the actual source. So this A through F picture sequence is just kind of a still frame capture by capture of what it would look like to work through whether or not you found a reflection or a leak. But let me show you what this looks like in real time. So I'm just going to play this video, and what you're going to see is you see the target. I've identified the target with the camera, but then I move left or right just to kind of pressure test it, no pun intended, and see if that target moves. And if it does, I continue to look for where the source is instead of just the reflection. So that'll come to life here. So I find a target, but when I move right, that target continues to move. I just kind of run through the logic test of where could that be coming from. Oh, okay, it's right up under that bench, and it's coming from the quick disconnect on that air hose. So that would be an example of what I would actually do out in the field. I turn on the camera, I find a target, I move left and right, up and down until that target stops moving, and I've isolated the leak. Okay, another thing that's going to happen is along with the reflections, you're also going to see what are called echoes. So in certain environments and noisy environments, you'll have different sounds that are bouncing off of walls and other surfaces, and they will be picked up by the sonic imager, the acoustic imager, but they won't show up as targets. They'll just kind of show up as blobs of color. They'll be in and out. And what you want to do is really look for those targets and not pay as much attention, if any attention, to the little blobs and things that you see on the screen. So I think this is just a really good example of what some echoes would look like out in a real life application. And then also watch as I just move from one viewing angle to another viewing angle to make sure that I've actually found where the leak is and isolate and pinpoint that location. Because typically in areas where there are leaks, there's a lot of different potential places where they could be. There's a lot of different fittings, connections, or air lines or gas lines or things like that. And so running kind of moving left and right and up and down and getting different viewing angles is a good way to make sure you've isolated the actual location of the leak. So you see the different kind of echoes and reflections popping up on the left-hand side of the screen. You've absolutely got a spot that you want to go identify and isolate there in that target. Kind of hard to tell with all of those different airlines in the field of view from that angle. So walking around to the other side of this application to figure out exactly where that leak is coming from. So as I move around on that other side and I've got eliminating all of the different echoes and reflections, it's pretty obvious that it's coming from the connection point on that center tank there. That's just an example of kind of the workflow and how you would use it out in the field. All right, another thing to keep in mind is that the different echoes and reflections that you see can also help you understand where in the facility to go and look a little bit further. So if I look at this still shot here on the left, I've got what appears to be a leak. I've got all of the characteristics that I want to see, right? It's not moving. It's got the full color palette represented by a circle. So that's all good, except for the fact that it's right in the middle of a steel beam, which doesn't make any sense at all. So what we're seeing here is it's actually a reflection of a leak that I am just a little bit under. So as I lift the camera up and get a little bit higher, I see that this reflection actually helped me to pinpoint a leak that I would have otherwise missed because I didn't have direct line of sight. So again, I'll play the video here and you can see how this plays out. As you move up and down, left and right, we were up on a little scissor lift here that allowed us to get a little bit higher up. But that leak was easily identified from the ground because of that reflection that we saw. So just a few examples of how this works out in the field. Now, we already talked about, being able to isolate a specific frequency range that you want to visualize sound within. But another thing that I want to call out here for the practical considerations is that you also see where the different sound elements in a field of view are coming from. So you see how we've got the frequency band isolated between 35 and 50 kilohertz. So that's great. Like, that's what we are visualizing on the actual screen. But the little orange wave that we see at the other frequency ranges are indicating other sounds that are present in the field of view but not visualized. So if you see peaks at different frequency ranges that you don't have isolated to visualize, that's a good opportunity to then just scroll that band down into the other frequency ranges where there's a high amplitude of sound, just to see if you've missed anything. So what I typically do when I'm out doing inspections is I'll set the camera to visualize leaks between 17 and 24 kilohertz, or even 15 to 25 would be a good fit. Because that what I've found is that's just a good balance between low enough frequency that I'm able to see a lot of different sounds, but high enough that I'm mitigating a lot of that ambient noise. And then typically what I'll do when I see areas that could be leaks, so I see those targets, is I will adjust that frequency range up a little bit more to isolate more of the, or to hone in more on that specific leak, and eliminate more of the ambient noise to get a tighter circle and pinpoint the actual location of the leak. So the takeaway here is set the frequency band to the right range for your application, but keep an eye on the amplitude at other frequency ranges that you're not visualizing on this scale here, and maybe just do a quick check if you see any peaks. Chris, I'm gonna pause there. We've gone through a lot already, and I know it's only been a few minutes, but I wanna see if there's any questions from the group here and get those answered.
Perfect. Thank you, Adam. We definitely have gone through a lot. We do have a question in here about a list of octave band that customer needs to test for. They're asking if they can send it in privately and have it be reviewed and commented on after this after the webinar. I'll answer that directly. Yes, you certainly can. You can send it directly to our customer service and sales department at sales@globaltestsupply.com. And we can loop Adam in the loop for that to answer any questions that you have to measure on that band. Another question that I have, Adam, is what would you suggest to a customer that needs and tests between 100 and 1,000 hertz?
100 and 1,000 hertz or kilohertz?
Question is in hertz.
Well, so I mean, if you've got, you said, what was the range?
Between 100 and 1,000. If the participant who did enter that question in could specify, if you do in fact mean hertz or kilohertz, that'd be greatly appreciated.
Yeah, I mean, and it could be hertz. So I'll answer the question as asked. So what you're asking for from a kilohertz perspective is essentially 0.1 to 1 kilohertz. I don't have a specific recommendation for that frequency range. I could speculate that the traditional ultrasonic kind of headphones with sensor heads, they may have something in that range. So this tool will not work in that frequency range. I don't have a great recommendation there, but what I would start is by like Google searching ultrasonic leak detection 1 to 100 hertz. So sorry I don't have a better recommendation for you there.
Perfect, thank you, Adam. If need be and willing to, the participant who did send in that question, please feel free to email us at sales@globaltestsupply.com for any follow-up questions, but we have plenty of time left in the webinar, so please feel free to submit any questions you have. As a reminder, please use the chat box. It should be at the lower right-hand corner of the toolbox. That's it for now, Adam. I'll let you know if we have any questions that come in.
Awesome, thanks. And for those that did ask questions, thank you. I appreciate it. It's definitely nice to get the engagement and interaction going. So keep it coming. You're not interrupting anything. This is for you. So make sure you get what you need from this session. All right, we'll jump back into it. So I had just mentioned conventional ultrasonic tools. So kind of a good segue here to look at kind of what has typically been used for doing the same work versus the II-900. So many of you have used or have heard of ultrasonic tools or traditional or conventional ultrasonic tools. What you've got is like a wand with a microphone and a cone. Connected to a meter, which has usually like a light and a sound indicator of different sound levels at varying frequencies, and then also connected to some headphones, so you can hear the ultrasonic sounds that your ears aren't typically able to pick up on. And so what I put together here is just some of the work that we did, understanding how the II-900 would differ from the conventional tools used for similar applications. So what you've got on the top is a trained professional using conventional tools to actually identify compressed air leaks. So what they're doing is doing a point-by-point scan, listening with a long-range sensor for areas that they want to go inspect a little bit closer to understand if what they are hearing, the anomaly that they're hearing, is actually a leak. So what they'll do then, once they've heard with the long range sensor a place to go look at a little bit closer, is they'll switch out the sensor head and use a pinpoint sensor head to confirm that they've actually found a leak. And then what they typically do, because they're out looking for them so they can fix them, is manually tag that leak and then either communicate with their internal teams to go out and fix it on a PM, or share that with a third-party contractor that's going to come in and do air leak repairs. So typically what we see out there with the conventional tools, that's that workflow, and it takes about 20 minutes for somebody that's trained in ultrasound to go from scanning a large area to pinpointing a leak to documenting that leak. And the workflow that we've improved here, or the opportunity for improvement with this technology, is really to do that same work, but do it a lot faster, and to do it with somebody that doesn't have the extensive training and experience with the conventional tools that you need to be able to use the conventional tools effectively. So with the II-900, there's no swapping of sensor heads. There's no back and forth scanning of a large area to verify that there is or isn't anything. It's really just a point and shoot application, and when you see those targets pop up on the screen, that indicates where you need to go and look a little bit closer and maybe change your angle to pinpoint the areas where there's a compressed air leak or a vacuum leak or some sort of gas leak or sound anomaly. So the new technology really just allows you to scan larger areas from greater distances, and to get through the identification and capturing of air leaks or opportunities to fix them a lot faster. Okay, a couple of application watchouts. So I've been out at a lot of different facilities, worked with a lot of different customers with this tool since we launched in April last year, and almost every week I get these application questions. So I wanna just kind of level set this group on a couple of different applications. So one, corona discharge. The II-900 will pick up on some, but not all partial discharge applications. So really this comes down to sensitivity. So some of the partial discharge situations are happening, the sound created by them are not big enough sounds or loud enough sounds for the II-900 to visualize. So I've seen plenty of applications where we can see corona or partial discharge or arcing and things like that, but we haven't been able to visualize all of them. So if the only application that would be a value add for you is arcing or partial discharge, corona discharge, I wouldn't recommend this as an alternative to what you're currently doing. It may help you in certain applications visualize some of those partial discharges, but again, I would just caution that it's not designed specifically for that application or able to definitively visualize all corona or partial discharge. Okay. The other one that I get quite often is refrigerant leaks. So yes, it will pick up on refrigerant and other types of gas leaks. It will, but it is not intended to replace the sniffers or other tools out there that are identifying leaks on the ppm scale or the parts per million scale. So in applications where we're talking about very small refrigerant leaks, as it pertains to either product quality or safety or some sort of environmental requirements that you need to meet within a certain spec, I would not recommend the II-900 as a replacement for existing tools for really small refrigerant leaks. It will, like I said, and I will show you some examples of places where it has shown, noble gas leaks, but it's not the same sensitivity as a sniffer. All right. So if you have want anything deeper there, happy to answer those questions. But just questions that I get all the time and wanted to level set the group. Okay, other frequently asked questions. How far away can I visualize a leak with the II-900? 164 feet is what we've spec'd. So now keep in mind there are some variables there, the size of the leak and also whether you have direct line of sight. So I've gotten quite a few questions around whether or not you can see behind a wall or through a panel or things like that. You do have to have direct line of sight to accurately pinpoint a leak. I have seen some applications where if there's like a little gap in a wall or a panel, you will see some of the noise created by a leak behind it escaping through those cracks or those voids. But if you typically you need direct line of sight, and when you have it, you can see at some pretty good distance. All right, the other question I get often is how many pictures can you store? So about 1,000 images saved directly on the device. It's also got USB out, so you can take the images from the II-900 itself, export them onto your computer and save them in whatever file structure you want, or create reports and things like that. Battery life is 6 hours. Fluke typically specs on the conservative side. So this 6-hour battery life is with the backlight all the way up and capturing a lot of videos and things like that. They're going to take up more of the battery. So I've absolutely been out in the field and spent more than 6 hours with the II-900 without charging it. But this is kind of like that worst case scenario conservative spec. So the battery life, it typically gets you through a full day's work if that's what you've got in store. All right, and then the other question, as we kind of started down the path of in the last slide, can you visualize more than just compressed air? Absolutely. I mean, I wouldn't even think of this tool as a compressed air leak finder as much as a kind of a sound finder. It will visualize sound within 2 to 52 kilohertz, regardless of what's creating that sound. So if I whistle, yes, it'll pick up on it. If it's a steam leak, a vacuum leak, or other gas leaks, as long as it's within that frequency range, it will be represented visually on the screen. Okay, leak estimation. So not only is the II-900 able to visualize leaks, It's also able to estimate the cost of the leaks that you find. So one of the different capture modes is what's called leak queue mode. So if you look at the picture in the top left, you see image, video, and then leak queue. You can select leak queue mode, and what that does is it'll populate a circle in the middle of the screen. And if you put an identified leak within that circle and capture an image, it will do a couple of things. It will capture not just the image, but all of the data behind it. So the distance from the camera to the leak, which is either automatically populated or manually entered. And then it'll also populate what's called a leak queue scale. So that's taking the distance and the decibel level and running it through an algorithm to then give you a severity scale on a magnitude of 0 to 10. And that's just allowing you to, kind of understand the severity of that leak on the tool. But once you capture the image, you can then input some of the variables for your specific applications, like the gas type, whether that's air or nitrogen or argon or CO2 or whatever medium you're working with, the system pressure, the cost per kilowatt hour, the amount of time that it runs in a year. There's a few variables that you enter, and then what it'll do is it'll output an estimated cost. So the report on the right hand side shows an example image, and then it's got there an estimated cost of $225 a year. So if you didn't do anything, that specific leak would cost $225. If you fixed it, obviously that would be the savings that you're able to gain from identifying and fixing the particular leak. Now, I've seen leaks that are big and in noisy environments, so were otherwise gone undetected, that cost up in the thousands of dollars per year. And typically in compressed air intensive facilities, it's not just ones or twosies on leaks, especially downstream of these compressors. They're in the hundreds. So the opportunity for cost savings really adds up. And the other thing that I think is really valuable that I've heard from our customers on this is, there's not a short list of PM activity to go do. Most facilities teams are not trying to look for things that they can do. What they're trying to do is figure out what the heck's the most important of their huge long list of things to do. And so this leak estimator is really valuable in helping identify what's the most important thing to go tackle in the next planned downtime. Right? What's the biggest bang for my buck if I go fix these 10 leaks or this one leak? What's going to have the most impact for the limited amount of downtime that I have. So that's another way where this is helping our customers, is not just understand the cost savings to communicate to the broader organization, which is great, but also to help prioritize the work that's being done. Okay, I've got some application examples. Chris, I'll pause here. Is there any questions that have flowed in since the last little break?
Looks like I got one. I will remind everyone, please use the chat feature if you have any questions. They can be answered on the spot while we have Adam and myself connected, so better to ask them now. So question, do you need to have a leak physical tag, or do you just transfer the pictures to the repair crew?
Yeah, good question. So the physical tags they're not necessary. That's just for the kind of what customers have typically done to help people go out and find where they need to do the fix really quickly. So you could do it however you want. You are able to capture images and then email them or print them out to share with whoever is going to go out and do the fixes. And you can also put in audio, or not audio, excuse me, but text notes and photo notes that would get saved along with any leak image that you captured. So you could capture an image of a leak and then put a note in there that gets saved along with the image that says something like, hey, I'm in building A, location 2C or by pillar 2C or whatever, the leak is on the south end of the compressor next to the regulator, like whatever, right? I mean, you can put those notes in that help direct folks that are going to be doing the fixing exactly where to go. You can also capture photo notes, like I said. So what I've seen in the past is like you've got a picture of a leak and then a photo note that you save with it. That photo note is just a visible light image of some sort of identifying mark. So maybe it's the picture of a serial number, or you know, the name of a motor, or something like that, or a compressor, or a specific part on a production line. So there, you don't have to, but you could, and you can also use things like text notes and photo notes to accomplish the same or similar things.
That's perfect. Thank you, Adam, and that's a great option to have. A reminder, everyone, if you do have a question, please use the chat feature. That is it for now. I will hand it back over to you.
Okay, cool. So let's go through some applications. So as I said in the beginning, we're not going to deep dive into the applications. I think a lot of them are relatively straightforward, but the objective here is to get the wheels turning. So I know that each of your applications, environments, industries, facilities are all different, and have different needs and requirements. So this is absolutely not an exhaustive list of all the different things that it could do. This is just a few examples to help you kind of think about some of the different opportunities that you might have. So again, it's anything where understanding where the sound is coming from, this tool can help. Okay, so somewhere where we see leaks all the time is just compression fittings on air drop downs. So what I love about this particular image is you're in, you know, a noisy production environment. You know, you've got conveyor belts running, you've got machines running, you've got guys with ear protection on in the background, but there's no doubt about where this leak is, and you didn't have to shut down production to go identify this particular opportunity for some savings. So and at a pretty good distance too. So just a cool example of how easy it is to identify a leak in an area where there could be leaks anywhere. I mean, there's hundreds of different potential leaks within, or areas where there could be leaks in this scene or in this field of view, but it's extremely easy to identify where that leak is, even in a pretty noisy scene. All right, most of the compressed air or compressed gas leaks that I find are downstream of the compressor. So I would say, you know, in the 8 months since this tool's been out, on all of the different visits that I've done with customers, I'd say about 90% of the leaks that I'm finding are downstream. But there are opportunities to find leaks right where the air is getting compressed, or where the equipment is you know, compressing the air. So here's an example, and pretty common where I see them, right? It's not typically, you know, a puncture in a line. It's typically at a T or an elbow or some sort of fitting. So while I would spend most of my time downstream of the actual production or the compression, there are opportunities to gain efficiencies right there at the compressor. An example of a leak on a regulator. A discharge valve connection, again at a fitting or a connection where you've got some sort of a hose transfer or reduction or something like that. Again, I mean, an environment like this, super noisy, right? I'm sure this is familiar to at least some of you. So in that noisy environment, to be able to, you know, without a doubt, know where to go and either, you know, turn a wrench to tighten something down, or to change out one of those components to get better efficiency, pretty simple. Here's an example on a production line at a food and beverage facility. You can take your best guess where this is at. Again, I mean, potential for leaks to be anywhere and everywhere in this particular field of view, and you know, without shutting down production to go find opportunities for savings, you just walk by at a safe distance, point the i900 at this production line, and find opportunities for cost savings. The other thing that's cool about this picture too is a lot of these kind of automated processes are dependent on compressed air, not only from like a cost saving standpoint, but there's also opportunities from a product quality standpoint. There's a lot of customers. There's a lot of customers that are using this i900 to find potential root cause for quality defects. I'll give you an example, and it's not related to this picture, but we do have a large beer manufacturer in the U.S. That just bought 23 of these i900s, and the reason why, or the primary application, I mean, they're going to use it for a bunch of things, but the primary application was detecting CO2 leaks on their production line. So they had recently gotten some complaints that they were manufacturing some less than ideal carbonation in their beer. And we were out with the i900 and actually found a couple of points on their production line where CO2 was leaking. And so it was reducing the amount of carbon dioxide that made it into their finished product. And so from a quality standpoint, that was the biggest opportunity for savings, not just that utility bill or that energy bill. All right, so this picture is kind of tough to make out, but I'll tell you the story. So this is an example of boiler tubes, and when these boiler tubes leak, for this particular customer, what they would do is they would hook up a compressor to the boiler tube network, and they would fill it full of air. And then they would send a team of 5 guys into the boiler tube area, or following these boiler tube lines, and they would literally have them listening for a hiss, or listening for where those leaks could be, to identify where it is and then fix it so they could get their operation back up and running. And what they were able to do is reduce the amount of time and labor on finding these leaks, because now it's just one person, and they're not limited by their ability to hear, but they're using the i900 to actually visualize it. So a job that used to take half a day and five team members is now just a couple of minutes and a single member of the team to accomplish the same task. I mentioned earlier, other gases or opportunities to identify other mediums. Here's an example of a natural gas leak. A lot of times you can smell these leaks, but when you're outside and the wind's blowing, that can be more difficult. And even if you smell it, sometimes it can be hard to know exactly where it's coming from, because usually these leaks are pretty small. So a natural gas example here. Here's another really cool example. This is a semi-truck manufacturer that's relying a lot on pneumatics for just the inner workings of the vehicle. And so as part of their quality control on their manufacturing line, they would actually have a team of people using different tools, the conventional ultrasonic tools, to go out and identify if there were any potential quality defects on their finished product. And so now they're using the i900 to do a quick scan and easily identify where they've got pneumatic leaks or leaks at these fittings. It's another example of a non-air application. So a nitrogen leak, again, right at coupling there, but a pretty expensive one there, and potentially dangerous as well, that the tool was able to pick up on. Ammonia as well, pretty big in the food and beverage industry, if that's where any of you all are working. So you can get rid of the sulfur stick and use the i900 to find those leaks on ammonia compressors as well. Yeah, so the sulfur sticks, they would actually have teams of people with a sulfur stick, like a punk almost, on the 4th of July, that's burning sulfur. And when sulfur interacts with ammonia, it would just make the smoke go crazy. And so that was a traditional method for identifying ammonia leaks, but this will work for that as well. argon. So here's a pretty spendy leak here, but coming right out of the discharge valve on the storage tank here. So even if it's not a kind of indirect cost savings opportunity through reducing your energy bill, there can also be these direct cost opportunities where this is a tank of expensive argon that this customer is using for their production process, that's just bleeding money out while it's sitting there waiting to get hooked up to their process. All right, here's the last one that I've got, and then we'll get into any remaining questions. But this is a pretty cool example as well. This is actually a vacuum situation here. So you've got this duct that's sucking out exhaust from a coal plant. It's sucking it out of the facility and piping it out, into the open air. But this was a huge safety concern for this particular customer, because if that exhaust starts leaking into their facility where there's not proper ventilation, it's putting their employees at risk of potential health concerns or whatever. So this was a pretty cool application and a good example of customers not limiting their thinking to compressed air, but thinking where would understanding sound or sound anomalies help either help me improve quality, improve cost savings, or keep people safe. So a pretty cool example that I wanted to share with you all as well. So again, that was to kind of get the wheels turning, to start thinking about the different potential applications you may have. Not an exhaustive list. It does a lot more, and I'd love to hear anything that you all find out there in the future, because the success story sharing has been such a cool process. I love hearing how different people are leveraging this technology to solve problems. So Chris, I'll turn it back over to you, brother, and we'll answer any remaining questions.
Perfect. Thank you very much, Adam. I'll take a moment just to thank you very much for the great presentation. Extremely informative. And I'll remind everyone that if you do have any questions, please enter them in the chat portion and chat section. As mentioned earlier, it's a great opportunity to enter any of your questions while you have myself as well as Adam on the line. If we are not able to get to your questions, or it's a more of a private question that you want us to send in, please use our sales@globaltestsupply.com email address. If need be, we'll send any technical related questions directly to Adam, and we'll have them answered as soon as possible. So I do have a question, a question that came in that was actually answered while you were going over the applications with the nitrogen line. Would it be able to detect bearing noises on a rotating axis?
Yeah, great question, and a really cool application. So simple answer, no. It's not able to pick up. I mean, it may pick up on bearing noises. You may see that, but what we're not comfortable with at this point is saying whether or not that noise is indicative of potential bearing failure, which I think is what you're kind of getting at. And if not, give us more color, or we can connect after the call. But for you and for the rest of the group, it is an application space that we've got our innovation engineers working pretty diligently to better understand and come up with a solution for. So that is a path that we're headed down. I couldn't give you any specific timing or anything like that. But wow, man, what a cool idea, right? To point a camera at a piece of rotating equipment and have it tell you visually whether or not you need to change bearings out. We're headed down that path. So stay tuned in and plugged in, and we're continuing to explore that and help bring solutions to that application.
That's great. Thank you very much again. Another reminder, we have about 5 minutes, folks, left in our time slot for this webinar. So please get as many questions as you can into the chat box. We do have a question about a rental unit. We're working on that, Global Test Supply. So again, stay tuned for that. You can email us directly. Again, email address is sales@globaltestsupply.com. Our customer service and our sales department will answer any and all questions related to price, availability, rental units, or anything of the like, anything technical that we can't answer ourselves. we will contact Adam directly and the Fluke team for any technical related questions that we don't get to by the end of this webinar. Another question came in, does air temperature affect the accuracy?
That's an interesting question. So air temperature can impact, you know, the way that specific flow is happening and things like that, airflow is happening. But we're not publishing an accuracy spec on this tool. So I mean, it could impact the decibel reading or the amplitude of the sound that's being picked up on. But really, I haven't run into air temperature impacting the ability to identify a leak. So maybe something that we need to connect a little bit deeper on, but generally I haven't run into any issues with varying air temperatures for identifying leaks.
Thank you, Adam. Another question in, can the spot be adjusted opaquely?
Ooh, I'm not sure I understand what the question's getting at there. Can the spot be adjusted opaquely? I'm gonna need a little bit more on that one to start down that path, but happy to do so. So
if we're not able to get to that, please, participant who did send in that question, it is a great question. It can be addressed after the webinar. Please send in your question to sales@globaltestsupply.com. It did come in. Broader definition is just to see the leak better. I guess maybe to expand the spot size or decrease the spot size to limit the size or the area of measurement, maybe.
Yeah, I get it now. Okay, thank you for that clarification. So I believe I get it. So I think what this person is saying is that so you've got like colors in a target overlaying a specific area. Can you get kind of tight? Can you do like blend the visible light more into that target to see exactly where it's coming from? So no, you can't adjust the opaqueness of the color palette, but what you can do is you can adjust the frequency range higher, and what that does is it will make that target smaller, because at the center of a leak there's higher frequency. As the sound expands or gets further away from the source of the leak, it's at a lower frequency. So if you scroll, we talked about adjusting the frequency. If you scroll that level up a little bit, you'll see that circle get smaller and smaller and smaller, and eventually it'll disappear. So you can fine tune the frequency band to get a better pinpoint location of the leak. So answering the question, no, but I would do something slightly different, and that is adjusting the frequency up.
Perfect, thank you, Adam. Folks, we have a little over a minute left in the time slot, so if you have any last minute questions, please enter them in now. Not sure if this is a question, but it does reference electrical line noise, and something that I guess the capabilities of the II-900.
Yeah, I totally agree. There's some really cool work that's being done there. Like it's similar to that Corona discharge application, you know, kind of on that electrical noise piece. Again, I would recommend, without making any timeline commitments here, stay plugged in with Chris. We're making some significant progress in that application space. So if that is a specific need, stay tuned in the near future. We're making some serious progress there. So thanks for that input.
Fantastic. Okay, well, that's all the time we have today for our webinar. Thank you very much, Adam, again, for the great presentation, staying connected to answer all the questions that we got. As a reminder, everyone, if your question was not able to be answered or you have anything further once the webinar is concluded, please email sales@globaltestsupply.com. Our customer service staff as well as sales staff will get to any and all questions that you may have. Anything technical that we need some Fluke assistance with, we will bring Adam back into the play as well. So thank you again very much, Adam, for the presentation. A reminder, an email will be going out shortly after the webinar, basically capturing everything that we had involved in the presentation today. The contest winner will be revealed on our social media pages, so please take a look at those and stay tuned for that. And also a reminder, a survey will be sent out after the webinar is concluded. We greatly appreciate your feedback, as well as submitting any topics for any future webinars that you may be interested in. Global Test Supply University is really interested in getting as many of these webinars out to you as possible. So thank you again, everyone, for participating today. Adam, a very big thank you to you. I wish you all a great and safe, happy rest of the day.
Right on. Thanks, Chris.